Hey, welcome back to Adrenaline Tutorial Empire. My name is Adrenaline, the Bazooka Prophet, and I'm very excited to be on your screen again. And for my fans all over the world, I say thank you for always commenting, always sharing, and also subscribing. Thank you. Now, today, we're going to be talking about a very interesting aspect of the gases law. The gases law. And on this part of the gases calculation, our interest is talking about the molecular speed of a gas. Molecular speed of a gas. This is for students preparing for A-level exams. A-level exams, undergraduates, Cambridge A-level exams. Basically, this part is for you. Now, under the molecular speed of gases, we have three major molecular speed. One, the root mean square velocity. Root mean square velocity. We have CP. CP simply means most probable velocity. Why? This side means average velocity, or this average velocity or average velocity. They both mean the same thing. Now, you need to take note of their formulas. Take note. The formula for root mean square is square root of 3RT over the molar mass. Now, please take note. The molar mass must be in kilogram per mole. That is to say, while you are doing your calculations, your molar mass will be the molar mass of the gas multiplied by 10 raised to power minus 3. In fact, let me put it like this. Because if you don't understand this part, to be a very big problem. And the unit of the root mean square velocity, or the unit of this molecular speed, are in meter per seconds. Meter per seconds. Take note, if they ask you to leave your answer in centimeter per seconds, after you have gotten your answer in meter per second, you can then convert it to centimeter per second. So let us solve this question. The question says, calculate the root mean square, the most probable velocity and average velocity for nitrogen at 25 degrees Celsius. It's very easy. We just move straight away. Solution is equal to the formula for root mean square velocity is equal to the square root. Take note, 3 multiplied by this arrow here is a gas constant in joule per mole per Kelvin, which is your arrow you are always making use of here is 8.314, right? Joule per mole per Kelvin, which should now be 8.314 multiplied by your temperature must be in Kelvin because of your gas constant here. So if you're having 25 degrees Celsius, convert it to Kelvin by adding 273. Adding 273, meaning 25 plus 273 will give me 298 over the molar mass of nitrogen. Of course, normally it ought to be here, is 14. Because nitrogen is a gas, right? Which is a diatomic gas. It will be what now? 14 multiplied by 2 to give me what now? 28 gram per mole. Remember, I've told you before, this is the formula. It will be 28 times 10 raised to power minus 3. Take note, you must add this one to it so that it can be in kilogram per mole, and that is how it is solved. So we just move straight away to calculate it. 3 multiplied by 8.314 multiplied by 298, 28 multiplied 28 times 10 raised to power minus 3, and the final answer to that would give me what now? 0.15 meter per seconds, and this is for the root mean square velocity. So I would need to rub this part, but meanwhile, take note of it. Let me rub this one now, so I can solve for the probable velocity. Probable velocity. Now, in the case of the CP, it follows this way. 2 multiplied by, of course, 8.314 multiplied by 298 over the molar mass again of nitrogen is 28 multiplied by 10 to the minus 3. What do I do? Put 2 here. That's 2 ROT. Okay. And the answer we should get here should be 420.68 meter per seconds. Is that clear now? So I hope it's clear. Okay. So I will erase this down here to create more space. Now the last of the question is to calculate for your average what? Velocity. And the formula is simply like this. Of course, 8 here multiplied by 8.314 multiplied by your temperature is also 298 over pi, which is 22, or let's say 3.142 multiplied by 28 times 10 to the minus 3. It's very simple. Okay, that's it. So the final answer would become 474.7 meter per seconds, and that is the final answer to this question. That is the final answer to this question. Now, do well to practice more examples, and if you need more examples to solve, you can as well send make a comment on the comment section below, and I will give you more questions. Thank you, and God bless you.